All right, well, we're working with exponential equations, and we got a problem here. That's something near and dear to my heart: compound interest. And we got a formula for compound interest, and it's actually just an exponential growth formula. We'll also look at exponential decay formulas. Well, let's start here by reading our problem. It says, find the account balance after 20 years if T is placed, if $100 is placed in an account that pays 1.2% compounded interest twice a month. All right, well, we got a little bit of thinking to do. I'll tell you what, let's look first at our formula. So we got our formula that is A amount equals P principal, original amount, times 1 plus R, that's the rate of return in decimals, over N raised to the power of N, N is the number of compounding periods, raised to the power of N times T, total amount of time. So let's look at this problem and let's then define our variables. All right, well, first off, A is what we're trying to find. We're going to try to find the amount after 20 years where we've received 1.2% interest compounded twice a month. So P is $100. Let's see, I think next we'll look at R. R is 1.2%. That's our rate of return. That's our amount of interest to be paid. And we're going to convert that to decimals by moving that decimal place 2 places to the left. So we got 0. So R is 0.12. Now N is the number of compounding periods, and we're told that we're compounding twice a month. Well, there's 12 months in the year last time I looked, and if we're compounding twice a month, that's 2 times 12, so N is going to equal 24. So let's see, we've got P, $100, we've got rate, our rate R, 0.12, we've got N, the number of compounding periods, 24, and now we're left with time, which we were told was 20 years. Well, now we're ready to solve this. So let's see, let's fill this out. So we've got A equals P, $100, times 1 plus our rate of return, 0.12, 0.012 divided by 24, and all of that is going to be raised to the power of 24n times time, 20 years. All right, well, first we want to work inside that parentheses. 1 plus 0.12 divided by 24. Unfortunately, in this case, it is kind of a number that's not too bad, so I'm going to write it down. So we got 100 times 1.005. And then that's going to be raised to the power of 24 times 20. Well, 24 times 20 is 480. We're raising this to the 480th power. Now, the next thing I need to do is take this 1.005 and apply the exponent of 480. We're going to raise it to the 480th power. And I'm not going to write that figure down because it's going to be, well, a long number. But I am going to take that and then multiply that by 100, and what we get is 127.12. And I rounded that to the second decimal place. Why did I do that? Because we're dealing with money. It only goes to 2 decimal places. Let's put our dollar sign out here. So $100 after 20 years, getting paid only 1.2% interest compounded twice a month, gives us $127.12. Not a lot of money. Save more money. Okay. Now, we're going to go graph this because we were also asked to graph this thing and see if what we found algebraically seems to make sense. And I'm going to move to the calculator in a moment, but before I do, I probably want to think about my window settings. Because, you know, in the default window settings in your calculator, you got X minimum of -10, X max of 10, X scale of 1, Y minimum -10, Y max 10, X and Y scale of 1. And that's, I got a feeling when I graph that, if I stay in that default or that standard window setting, I'm not going to see much. So let's think about what I need to change on my window setting. Well, X is the amount of money. That's how much money we're talking about. X values. No, excuse me. X is time. X is time. X is time. Well, I can't have less than 0 time. So I'm going to set my X minimum to 0. Now, X maximum, I know I'm going to make a prediction out at least 20 years. I'm going to use my calculator actually to confirm my algebraic answer. So I'm going to set X max out to 21. And, you know, normally every little tick mark is, we have 10 tick marks usually. So I'm going to set my X scale to 2. So that means I should be able to see from 0 moment in time out to at least 20 years. I set the X maximum at 21. I want to get just beyond what I know that I'm going to use as a prediction in this function. And now let's think about Y minimum. Now Y minimum is going to be the amount of money with respect to time. Well, let's see. I shouldn't have less money than I started with because I do have at least a positive interest rate. So I'm going to set my Y minimum to 0, and I'm going to set my Y scale to 150, because I'm trying to get actually just a little bit beyond the 127. I probably could have set it at 130, given I've done an algebraic equation. And you can't see the Y scale because it's behind my face there, but I'm going to set it for 15. Let's see. So I think that should give us pretty much good to go. All right, so we're going to go over to the calculator and we're going to graph this. We're going to put in those window settings first. Then we're going to graph this function where my variable is t. And I'm going to substitute x for t. But let's move over there and see how we do. All right, well, here we are on the calculator, and as promised, the first thing I'm going to do is change those window settings. And remember, I said I was going to set the X minimum to 0 because I'm not going to have negative time. And then I set the X max to 21 because I know in our problem, we went out 20 years. And so that I could actually see something, I'm going to set my X scale to 2. So that means I should see every 2 years on the X scale. And then on my Y minimum, I'm also going to set it equal to 0 because I shouldn't have less money than what I started. But I am going to set my X max, and I chose 150. I probably could have chosen 130, but I'm going to choose 150 for my X max. And then I'm going to change my Y max. And then I'm going to change my Y scale to 15. And now let's go punch in this function. Well, y is equal to a in this case. And so then I've got 100 times 1 plus, and I'm going to put another set of parentheses in here. I'm going to take my rate, 0.012, that's 1.2% interest, and I'm going to divide it by my number of compounding periods, and we're compounding twice a month, or 24. I'm going to close that parentheses, close the original parentheses, and now I'm going to raise this to a power of 24, my number of compounding periods, and I'm going to use the variable x for time. So my variable is in my exponent. And let's go to the graph and see. Hopefully I've done this correctly. All right, well, at least I get something on the screen. So based on the way I set my window settings, that's what my function graph, that's what the graph of my function looks like. And now I'm going to ask, okay, well, what's the value when x is 20? In other words, what's the value of y, the amount of money, y, when x time is equal to 20? So I'm going to hit second trace or calc, and I'm going to choose option 1, value. And I'm going to say when x is 20, what is y? So I hit x equals 20, I hit enter. And Shazam, I see that y is equal to 127.12. And Shazam, you know what? That's exactly what I found algebraically. How about that?